Hello my dear students, welcome back to NEET WORLD. So today as a part of our bridge course, we will be discussing the basic types of organic chemical reactions that we have. So if you have seen in the last sessions, we were clearly discussed the required amount of IUPAC nomenclature for organic compounds, and we have solved some questions also, PYQs also. Then I explained something related to isomerism. Okay, so these were the things that we discussed from organic chemistry part, right? Then next, today we will be seeing what are the types of chemical reactions we have. Okay, so now if you see normally the chemical reaction, if you take how the reaction takes place, how a chemical reaction takes place. So in the last class also I have given some idea on this. Anyways, I will be explaining here once again, just follow me. See, organic reactions and fundamental concepts here. Okay, let me explain this. Yeah, so generally organic reactions means what I told you, there is something called reactant and converts into products. Okay, converts into products plus some byproducts also forms sometimes. Okay, and during this reaction, whatever the conditions we are maintaining, we should mention here. It means కొన్ని reactions కి ఒక particular temperature దగ్గరనే జరుగుతుంది కదా, so that temperature should be mentioned here, whatever the specific temperature that is required for the reaction to be mentioned here. Okay, and sometimes some reactions require particular pressures also. Yeah, you can write that pressure also here. Okay, for example, this reaction is taking place at 100 degrees Celsius, maintain here. Okay, and this reaction required some 2 atm atmospheric pressures. Okay, you maintain there. Okay, and this particular reaction required some catalyst, you mention the name of that catalyst over here. Okay, like this reaction conditions are mentioned. Okay, now this reactant has two parts. What are the two parts I am saying? One is called substrate, the other one is called attacking reagent. Okay, so this reagent will attack on the substrate. That is how the reaction starts here. Okay, once again, this reagent will attack on the substrate. Okay, I will give you examples, no worries, just listen to me. Okay, so when it is attacking, sometimes reaction requires some acidic condition, basic condition, you mention it on the arrow mark. Okay, that's it. So once it is attacking there, we may get something called intermediate. What we are going to get? Intermediate. Okay, so sometimes it will be intermediate, or there is no intermediate, sometimes directly product formation takes place. If directly product formation is taking place, there we will see something called transition state. What is that called? Transition state. So this is how the basic structure of a chemical reaction looks like. Okay, next, finally it will give us the product, and some byproducts are also formed here. Okay, so you can mention it as product, that is enough. Next, here we'll be discussing something more interesting. See, so what do we mean by intermediate? Yeah, so this intermediate comes from the substrate. For example, substrate is something like this, CH3Cl. Okay, methyl chloride I have taken. So since chlorine is more electronegative atom, this bond may get polarized like this. Okay, so now if it is polarizing, you are going to see a positive charge here, partial positive charge. If this carbon is more stable with positive charge, once again, if I remove chlorine completely, now whatever the charge I am generating here, if this carbon is more stable on the if this positive charge is more stable on the carbon, then that intermediate is called carbocation. What is that intermediate called? Carbocation. Why I am saying carbocation? Because if I remove these bonded electrons with the chlorine this side, now what happens? You are generating a positive charge over this carbon. So whatever the charge we are seeing here, now just count the electrons, 1 2 3 4 5 6. So 6 electrons are there around this carbon, means, so can I say this carbon is electron deficient? Yes, this is electron deficient. So carbocations are electron deficient species. What they are? Electron deficient species. So you can say carbocations as electrophiles. What they are? Electrophiles. Electron deficient, na? So that's why they want to accept the electron. See, whenever we are having something less, we will try to get them. For example, we are thirsty. What we will do? We will try to take some water. We are hunger. We will try to take some food. Here also, electron is having deficiency in the carbocation, that is nothing but electrophile, is having deficiency in the electrons. That's why it is try to gain the electron from others. Okay, that's it. Okay, so like this we have some intermediates. So what are the reactive intermediates we are going to see? Something like carbocation, okay, and the next carbon anion, okay, next free radicals, next carbenes, next nitrines. So these are the intermediates you can study as of now. Okay, there is called benzene also, all these things. But yes, someone in the comment box, hi, think it is Gokul. Yeah, up to here it is clear, I hope. Yeah, so like this we have intermediates. So that intermediates may form, on that intermediate we may add this reagent that gives us a final product. Okay, right. So now based on this, how many types of reactions we have? The basic structure of organic reactions is clear, right? So try to write that basic structure. Then after that, how many types of organic reactions we have? One is called combustion reaction. The next one, oxidation reaction. Okay, next addition reaction, substitution reaction. So if I say oxidation, there might be reduction reaction also. Okay, now here oxidation reaction is an example, like all combustion reactions are examples of oxidation also I can say, because here I have methane. Let us say methane is there. So methane, I am adding this oxygen. So what is this process called? Addition of oxygen is called oxidation. What is that called? Addition of oxygen to any other things considered as oxidation reaction. Now what happens here? CO2 plus H2 is forming. So I can simply say this as a combustion reaction or also an oxidation reaction. Why? Because combustion of any substance required oxygen. Upon combustion it gives you this product. So to this carbon I have added oxygen, to the hydrogens also we have added oxygen. So we can say this as oxidation reaction or also combustion reaction. So combustion reactions are examples of oxidation reactions you can say. Okay, hope the discussion is clear up to here. The next, addition reactions. Addition reactions means to the given substrate, what I am saying, to the given substrate, if you are adding anything, if you are adding the reagent, that gives you the final product. So you are adding the things to the substrate, you are nothing removing from there, you just adding the things to the substrate, then that is called addition reaction. See the best example here, you can see what I am doing, CH2 double bond CH2 we have. To this I am adding hydrogen molecule. What I am adding? Hydrogen molecule. So this process takes place in presence of platinum, palladium, catalyst. Okay, platinum, palladium, nickel, platinum, palladium like catalyst are required. Now what I am doing is H2 molecule means it will be like this, right? Yeah. So you can add across this pi bond. It means here we have a sigma bond and a pi bond is there now. So pi bond is relatively weaker bond. Therefore, by removing this pi bond on each of these carbon, hydrogen atoms were added. So that you are going to see something like this. So what you have did here, you have added the reagent over the substrate. You have added hydrogen atoms over the substrate molecule. See, we haven't removed from the starting material, we just added to the starting material. So you can say this as an addition reaction. What is that reaction called? Addition reaction. Hope the discussion is clear up to here, right? Is this clear or not? Guys, if the discussion is clear, hit on the like button. Okay, if any confusions are there, please mention. Yeah, see, one more example of addition reaction. See here what I am doing. Here I am adding HBr. What I am adding? H and Br. We know HBr, HCl, all these are acids, hydrochloric acid. This is hydrobromic acid. So these are acids, stronger acids. Okay, now we know if it is an acid, it releases H plus ion. and the remaining part will be remains as Br minus ion, right now. So you add H plus on one carbon and Br minus on other carbon, so that you are going to get a final product like this, CH2, CH2. So one carbon H, the other carbon Br. Okay, so what you did, you have added HBr across this double bond, right now. So it means you just adding the things to the substrate, then you can simply say it as addition reaction. What is that reaction called? Addition reaction. Okay, so now these addition reactions further classified as electrophilic addition, electrophilic addition, electrophilic addition reaction, nucleophilic addition reaction, and the next free radical addition reaction. What are the three things we have seen? Electrophilic addition, nucleophilic addition, free radical addition. Okay, I will tell you about them, but first of all be clear with the names. Okay, if you are adding something to the substrate, you simply call it as addition reaction. Particularly in that, further classified as electrophilic addition. If you are adding an electrophile, then you can say it is an electrophilic. If you are adding a nucleophile, nucleophilic. If you are adding a free radical, then you can say it is a free radical addition reaction. Okay, hope the discussion is clear up to here, right? Next one, substitution reaction. So even in the substitution reactions also further classifications are there. Okay, so I will tell you with the example. Substitution reaction, name itself saying now you are substituting something from the substrate. Once again, from the substrate you are removing something and you are inserting the new thing. So it means one group is removed, the other group is added. So like that, substitution, like substitute player in the game, like when we are playing kabaddi or any other game, what we will do, we will take the substitute player. By removing one player, we will be taking another player, right now. So here also one group is removed, that whatever the group we are removing, that is called a living group. What is that group called? Living group. So another group is entering now, so that is called incoming group. What is that called? Incoming group. Okay, one group goes out, another group enters in. So that is what happens in the substitution reaction. Okay, so now here, as like we did there, here also we have further classification, like electrophilic substitution reaction, next nucleophilic substitution reaction, next free radical substitution reaction. So in the short forms only I am writing, so that we can save the time, but if you want you can write in the extended format. Okay, but the concept is important. Okay, right. Yeah. Next thing, okay, next thing here we have is, let us discuss about these basic things. First of all, combustion reaction. See, combustion reaction means, already I told you, this is an example of oxidation also. Okay, the carbon here, the carbon definition, carbon and most of its compounds burn in oxygen to give carbon dioxide along with the release of heat and light. See, we are using carbon like coal or any other carbon containing compound as a fuels. Why we are using them as a fuels? Because upon burning them, upon combustion of those substances, it releases high amount of energy. That energy can be used for running of vehicles or cooking purpose or any other purpose we are using. So we can call them as fuels. What we are saying them as fuels. Okay. So now see here, carbon is treated with oxygen. You are going to get carbon dioxide along with the liberation of heat. So this is an example of what? Combustion reaction. Similarly, methane reaction also we have. Okay, like this. So that's why we are using like LPG, petrol, diesel, all other things like natural gas, like methane. All these things are used as a fuels. Okay, right now we are using LPG, like that is nothing but isobutane only. Okay, that is also carbon content. Okay, so now where we will be using it? Domestic purpose, for cooking purpose. So that is nothing but a fuel. Okay, right. So all those reactions, whatever the combustion reactions we are seeing, these are oxidation reactions only. Okay, next. So we are, okay, so that is one type of combustion reaction is done. So next type of reaction we have is oxidation reaction. So what we are doing is occurs in presence of oxidizing agent. So oxidation means what? We need to add oxygen to the given substrate, then we can say that process as oxidation reaction. Once again, addition of oxygen is called oxidation process here. Okay, it means to the given substrate, to whatever our starting material is there, that is called substrate here. To the given substrate, if we are adding oxygen, then you can say this process as oxidation process. What is that process called? Oxidation. Okay, let me show you here. So CH3, CH2, OH, this is called ethyl alcohol. So to this ethyl alcohol, I am adding something called KMnO4. So KMnO4 is called as potassium permanganate. So what is this called? Potassium permanganate. Okay, so if you are not aware of this, exact representation is given, I mean exact practical demonstration is mentioned in our NEET World YouTube channel. Just go through the video section. Okay, so there I have like my thumb, like there will be a video with my thumbnail, with my face, like holding two test tube. You just watch it. I have shown you the practical demonstration in that video explaining about oxidation of alcohols using KMnO4. Okay, you just watch it after completing this session. Okay, don't skip that, it is interesting, you can watch it once. Okay, now what happens is this potassium permanganate is an oxidizing agent. What do we mean by oxidizing agent? It will oxidizes other substances. See, it is reacting with this now, so it means this compound undergoes oxidation. So what is the duty of an oxidizing agent? It oxidizes others. Whoever reacting with this oxidizing agent will get oxidized. So this is the thing reacting with KMnO4 now. So it means it will undergoes oxidation. Okay. So now upon oxidation of primary alcohols, you will get respect to carboxylic acids. What we are getting? Carboxylic acids we are getting. See, in the starting material, in this substrate, how many oxygens you have seen? One oxygen you have seen. But if you observe here, how many oxygens we are seeing? 2 oxygen. So it means what we did during the process, we added extra oxygen, we added one more oxygen. So you can say it is an oxidation process. Okay, hope the discussion is clear. Addition of oxygen is called oxidation, and one more definition, removal of electrons is also called as oxidation, or removal of hydrogens is also called as oxidation. But as of here, what we did, we added one oxygen. Okay, what we did, we added one oxygen, so it is an oxidation. Now one more thing you can observe, how many hydrogen atoms are there in the starting material? So 3 plus 2, 5 plus 1, 6 are there. But if you observe here, only 4 hydrogens are there. So we also removed hydrogen atoms. So in the perspective of hydrogen atom also, removal of hydrogens is also called as oxidation. Okay, hope the discussion is clear about this oxidation reactions. Okay, so now we can use oxidizing agents like KMnO4, K2Cr2O7. So this is called potassium dichromate. It is an orange color substance, whereas this is a violet or pink color substance, purple color substance, you can remember. Okay, hope the discussion is clear up to here. So what I told you, you watch the video that I have made in which explaining or showing the practical demonstration of KMnO4 reaction with alcohol. Okay, even in the shorts also, YouTube shorts also it is there, you can watch it once. Okay, then next. So this is the story of oxidation reactions. The next reaction is reduction reactions. What is that called? Reduction reactions. Reduction reactions. So reduction reactions means you can do, what you can do here, addition of hydrogen atoms. Hydrogen is called reduction reaction. Or you can also do addition of electrons is also a reduction process. Or you can also do, see, oxidation means we are adding oxygen, removing hydrogens. So here it should be reverse. Reduction means adding hydrogens, removing oxygens. So removal of oxygen also we can do. So these are the 3 ways we can do this reduction reactions. So let me show you one example. Here what we have, see, carbon with double bond O H we have. Like this we have. Otherwise, let us take this and some alkyl group R. Okay, to this carbon, what we have, oxygen is there. Okay, do we have any hydrogen here? No hydrogen, but what I am using here is something called reducing agent. What is that called? Reducing agent. See, for oxidation purpose, we used oxidizing agent. For reduction purpose, we are using reducing agent. So, lithium aluminum hydride is the best example of reducing agent. What is that called? Reducing agent. Okay, so it reduces this carbonyl group, this carbon, into some other format. See here what I am doing. So, lithium aluminum hydride. When I say chloride, you are taking chlorine as minus. If I say fluoride, you are taking as F minus. Bromide, Br minus. Here I am saying hydride, it means H minus. What it is? H minus. So, lithium aluminum hydride gives us H minus. So, that H minus will be added onto this carbon. So, addition of hydrogen. What is that process called? Reduction. So, now what happens is, so Cr, you are adding hydride ion now, it will becomes like this. O minus, it becomes first. The next upon following hydrolysis gives you alcohol. Okay, once again. So, reduction of ketones, once again, reduction of ketones gives you alcohols. Okay, and if you want to do further reduction, just remove this OH group. That gives you alkanes. Okay, so what is that reaction called? That is called Clemmensen reduction. Anyways, I will be mentioning here direct reaction only. So, ZnHC. So, this is a specific reagent we need to use during the process. So, ZnHG. So, zinc amalgam you can say, and acidic medium is required here, gives you RCr as it is. See, what I am doing is removal of oxygen. What I am doing? Removal of oxygen is called reduction. No? So, I just removed oxygen, then placed with hydrogens. Okay, this R group as it is. So, one hydrogen, the other hydrogen. So, what I did here? So, ketones converted into an alkene. What happened? Ketone converted into alkane. What I did here? Removed oxygen, placed two hydrogens. So, addition of hydrogens, removal of oxygen. So, this is called reduction. Particularly, what is the name of this reduction process? This is reduction we know. What is that reduction called? Clemmensen reduction. What is that? Clemmensen reduction process. Okay, hope the discussion is clear. Okay, without having any confusions, right? Yeah. If this is clear, please mention clear in the chat box. Okay, let's move forward then. So, I told you about addition reactions. So, what I told you, we are adding something to the substrate, then we can say that process as addition reaction. Okay, we haven't removed anything. So, reactions in which saturated hydrocarbon adds unsaturated hydrocarbon add hydrogen in presence of catalyst to give saturated hydrocarbon. So, alkene is converting into alkane now. So, these are called unsaturated compounds, these are called saturated compounds. So, alkenes are unsaturated converting into alkane which is a saturated. Okay, that is it. We already discussed about this. Yeah. Next, substitution means what I told you, it is classified again into three types. I told you: free radical substitution, nucleophilic substitution, electrophilic substitution. Here we have an example of free radical substitution. Okay, so now look at this definition: the reaction in which one or more than one atoms or group of atoms get replaced by the another atom or group of atoms. See, for example, here I have something like this. So, let us say CH3X is there. So, now this X is replaced by some other group G. Okay. So, now what is happening here? CH3G. So, now what you did? So, removed X, replaced it with G. Okay. X is replaced by G. So, that is nothing but X is substituted by G. So, you can simply say it is a substitution reaction. Okay. So, in this case, it might be only one group, that is mono substitution takes place. It may be multiple group. Two hydrogens or two groups can be substituted, or all four can be substituted. Like that, we have, based on the type of reaction, we have different substitution products. So, the first one here, The example that you are seeing here is called free radical substitution reaction. So what do we mean by free radical first? See, during the free radical substitution reactions, generally the reaction happens in presence of sunlight. What I am mentioning? Sunlight. Okay, or it may takes place in presence of high temperatures. It either required sunlight, or we can also represent it as H nu, means suitable frequency were used in the reaction, or it can be represented with a high amount of temperature, like delta is a symbol for representing heating condition. So now what happens is, let us write the same reaction once again. So I am writing this as methane plus Cl2 giving rise to some product. Okay, let us say CH3Cl is a product I am saying. Okay, so this takes place in presence of sunlight. So now what happens here is, see, if you observe chlorine, it is a symmetrical molecule, right? Now symmetrical reagent or symmetrical molecule you can say. So when you use a specific frequency, so sunlight is nothing but sun rays will come and fall onto this bond now. So now what happens, if that light energy is sufficient to break this bond, then this bond, both atoms are same now, so it will breaks into two equal halves. So chlorine, like that, chlorine one radical and the chlorine with one more dot. So what is this dot indicates? Because one bond contains two electrons now, so bond is cleaving into two equal halves, means it will be represented like this. So you are going to get radicals. What you are going to get? Chlorine free radicals, chlorine with one electron, another chlorine with one electron. Simply you can write this as two chlorine radicals are produced. See, whenever you are writing any atom with one electron on it, you can call it as a free radical. What you can call? Free radical. Say radical means electron, it is freely sitting on it, so free radical. Simply understand in that way. Okay, right. Okay, so the next thing is free radical is generated. So these free radicals attacks on our substance, because free radicals are very unstable, so they are highly reactive. If something is unstable, it will be having more reactivity. Whenever we say something is very unstable, it has more reactivity. Okay, so in our daily life also we will see some people like simply shout on others because their mind get altered with different thoughts. Okay, they have some fluctuations. Okay, so that's why we'll see them as very aggressive right now. So here also free radical is highly reactive. So now what it will do is, it will try to react with this compound. See, but in this compound 4 hydrogens are there like this. It means all 4 bonds are equally energized. It means all of them are same. Okay, so one of this hydrogen is taken by the chlorine. Let us say this hydrogen is taken by the chlorine. See, they have one electron. In order to make a bond with this hydrogen, just they require one more electron. So out of this 2 electron, it will be taking only 1 electron. So you are going to get CH3 dot plus HCl. You are going to get CH3 dot HCl. Okay, so this is methyl radical we can say. Like this, how many chlorine radicals we got initially? 2 chlorine radicals we got. 1 chlorine radical got reacted here. So one more chlorine radical may have chance to react with this methyl radical, and we may get a product something like this. Okay, so otherwise this methyl will themselves react, we will get ethane compound. All these combinations are there, but now we do not want all those in deeper concepts, but whatever the things is required, I hope it is clear. So free radical substitution mechanism means what happening here. So out of these groups, out of these substituted 4 groups, one atom is replaced by chlorine. By following what mechanism? By following like generation of free radical. That free radical is substituted onto the carbon by removal of hydrogen radical. So you can simply say it as a free radical substitution mechanism, because one free radical is substituted by another free radical. Okay, so like this mono substitution takes place. Now I can remove 2 hydrogens, I can place 2 chlorines, or can remove 3 hydrogens, I can place 3 chlorines, or I can remove all hydrogens, I can place chlorines. Like that, monochlorination, dichlorination, trichlorination, polychlorination, like that polyhalogenation, polysubstitution takes place in the given compound in free radical substitution mechanisms. Okay, right. Let's move forward then. This is about free radical substitution. Now look at this. Read the question once. Chlorination of ethane. Chlorination of ethane. See, simply out of these reactions, I will show you some differences. CH2, you are adding chlorine. So what is this called? This is ethene. What is this called? Ethene. To that you are adding Cl2. Like I told you, when you are adding hydrogen, what happened on one carbon and the other carbon of this pi bonded system? One hydrogen is added onto both of these carbons, so that you will get something like this. I told you, hydrogen here and here, like this. So in the same way, when you are adding chlorine, what happens? You just remove pi bond, adjust this chlorines on it. So you will get CH2, one chlorine here, the other chlorine here, like this. Okay, this is about ethene story. Now the question is about ethane story. Now look at this. Ethane means CH3 chlorine. So they are saying chlorination of ethane. Now here I discussed about chlorination of ethene, that is ethane. Okay, now see, do we have any reactive site as we seen here? See, pi electrons are weaker electrons, they can react with the chlorine, but there is no such pi bond here, only sigma bonds are there. So now what I am saying is, for this purpose we require specific thing like mention of sunlight or high temperatures. Okay, now what happens? First, here, from here you will get chlorine radicals. So that chlorine radicals will replaces one of this hydrogen. You are going to get something like this: CH3, CH2, Cl plus HCl. So what we did here? Substitution taking place. Which substitution? Free radical is involved now. For free radical substitution is taking place. So as per the question, chlorination of ethane is a type of substitution reaction. So for this particular question, your answer should be 4. Okay, because substitution only taking place here. Now if my question is chlorination of ethene, what is that process? See, chlorination of ethene involving addition of 2 chlorines onto the substrate, like this. So you can simply say it as an addition reaction. So just by looking at the process that is taking place, you need to say whether it is addition, substitution, elimination, all these types. Okay, hope the discussion is clear up to here. Right, let me move forward. Yeah, so once read these statements, which are the following statement is or incorrect? See, we discussed alkaline KMnO4, oxidation of alcohols. What is that? It is an oxidizing agent, right? KMnO4 is a reducing agent. This is incorrect now. So what I told you, KMnO4 is oxidizing agent. It can only act as oxidizing agent. Combustion is also type of oxidation. Perfectly correct. Oxidation reaction changes the saturated hydrocarbons. Addition reactions changes saturated hydrocarbons to unsaturation. Is this clear? Is this correct? No. We know addition reactions changes unsaturated compounds to saturated, like alkenes is converted into alkanes. So these are unsaturated. Alkenes, alkynes are unsaturated, converts into alkanes that are saturated. So the statement is in reverse manner. So remove this. Okay. So what are the incorrect statements? 2, 4. 2, 4 are incorrect. Next statement, chlorination of methane occurs in presence of sunlight. Yes, right. So because it is an alkane. Alkanes are highly stable. In the previous slide also we discussed. See, this is an alkane. Alkanes requires specific higher temperature or specific conditions like sunlight, but alkenes easily reacts. Okay, so reactivity of alkanes is very, very less. That's why we require high temperatures or sunlight or suitable frequency. Okay, so here methane is an also simple example of alkane, right? So it also requires sunlight for chlorination purpose. Okay, so this is correct. Chlorination of methane occurs in presence of sunlight. Perfect. Next, NaBH4 is not an oxidizing agent, like I told you about lithium aluminum hydride. So here it is sodium borohydride. So this is a reducing agent, not an oxidizing agent. NaBH4, they are mentioned it as oxidizing. No, it is a reducing agent. So what are the incorrect statements out of this? 2, 4, 6 as your answer. Okay, so like this in the exam we may expect like a few statements, and they will ask us to identify the correct and incorrect statements. What are the incorrect statements from the given 4 or given 5 statements? Like this we may see the statement based questions also. Okay, right. See, whatever we discussed, I hope everything is clear without any confusion, and the questions also related to our discussion only, strictly based on our discussion, right? Yeah. Next. Okay, so the remaining things like we have different types of reactions we have seen now. So in the different types of reaction, in order to understand their mechanism and their sub classification, further classification, for example, I told you about nucleophilic substitution reaction. Okay, nucleophilic substitution reaction further classified as like SN1 and SN2. Like this we have further classifications. No worries, I will explain you that like anything, like you cannot miss even a single question from this kind of reactions or whatever the reaction. Okay, so with that much confidence, with that much clarity, we are going to discuss them in the future classes when we start our the real classes. Okay, not now. Okay, because it requires strong command over these electronic effects, which we are going to discuss in the organic chemistry part of our daily classes. Okay, so no worries, don't bother about these things, I will be discussing about them, and whatever the other remaining basics we required for understanding of class 11th and 12th chemistry, we will be discussing them in the upcoming sessions. Okay, until that you stay connected with this NEET World channel, and if you are looking to join with us in your NEET, JEE, EPSET exam preparations, you can reach us to the mobile numbers provided in the description box. Okay, so thanks for watching. Any confusions or any doubt, please feel free to write in the comment box. Thanks for watching, stay connected.